Welcome everyone to our new webinar series, Architectural Fusion, which Majabeen Memon will give a short introduction about what it is. So I'm Lalaruk from Climate Action Pakistan, and we have with us today Majabeen, who is from MAS, which is Mehran Architectural Student Society from Mehran University, Jamshoro, Pakistan. And for the launch of this webinar series in today's first episode, today we have Henning Brand with us, who has tons of experience working in renewable heating in industry. But today he's gonna help us learn more about renewable heating in terms of for buildings and industry as well. I'm glad to introduce that Henning has also working experience in multiple projects in Pakistan. So welcome everyone. I'll invite Majabeen first to introduce about this new initiative that Climate Action Pakistan and MAS collaboration is going to do over the next couple of months.
Hello everyone, I am architect Majabeen Mehman. I am here to welcome you all to Architecture Fusion, where sustainability meets design. Special thanks to the founder of Climate Action Pakistan for collaborating with MAS. Today, join us as Henning Brand enlighten us on renewable heating for building and industry. Let's explore the architecture and sustainability together. Thank you for joining us on this journey. Thank you, Lalaruk. Thank you, Hannibal, for joining us today.
Yeah, thank you. Just a bit of housekeeping. So participants can't unmute themselves. There's a question answer box for all the questions. So please put your questions in the question answer box during the session, and we'll take all questions at the end. And regarding the certificate thing, I'll be sharing a link in the mid of the webinar. Please fill that Google form to receive your participation certificate. Over to you, Henning, and you can start your session. And I think I can jump into between if I have any questions and if I want to add something. I hope you can share your screen.
Can you see my screen?
Yes, we can. Thank you.
Great. Move this over here. Okay, so yeah, thank you for the opportunity to share a bit about this exciting topic. So I am I'm working with renewable heat on a daily basis. I have done so for 10 years in different sectors. I started out a lot working with renewable heating for buildings such as hotels and residential. And the last 3 years, I have focused on industrial heating. So focusing on the different factories that consume a lot of heat. So this will be, as the title says, fusion. It will be some fusion of those two experiences. I'm not a professor or anything like that. I'm an entrepreneur that has discovered how much potential there is in renewable heating. So I will share that potential with you in the next few slides, and then we will obviously have a question and answer session. So what I would like to start with, if I can press somewhere here, is this picture. So to recognize that heating is half of the world's energy demand, is the way we consume heating in our buildings as well in our industry. So if you have a look at this pie chart, you can see that we do need electricity for our laptops and for our lighting and such equipment, and we need energy for the way we transport ourselves and our goods. And then the main chunk of the world's energy demand is often missed in these discussions is this block here called heating. And that is that contributes to 40% of global CO2 emissions. the way we need heat in the world. Cooling is part of it as well. It's both cooling is in these parts as well. So I share a little bit about how cooling and heating are related. So when I say industrial heating, then we all consume different goods on a daily basis. We eat, we wear clothes, we use paper, we eat cheese or drink dairy products in different forms, consume beverages and pharmaceuticals. When you look at the factory like this, it is consisting about 70 to 75% of a factory that produces these goods is consuming heat. So let's look at the dairy industry. So the dairy industry, we have processes such as separation, pasteurization, the cleaning, evaporation, the drying. If we look at brewing, there is mashing, boiling, again cleaning, bottle washing, pasteurization. If we look at the textile industry, we use dyeing, drying, heat settling, washing, bleaching. I've looked at, as Lala mentioned in the beginning, I've looked at several textile factories in Pakistan that consume a lot of fossil fuels in the process of producing the clothes that are being sold to maybe companies like IKEA, H&M, Swedish companies, where I'm from. So that is often done with coal. And if we look at how much, if you produce 1 kg of clothing, you would consume 2 kgs of coal. That's the ratio that a kg of clothing consumes to produce. The tea industry is another process that uses a lot of heat, and often they burn down trees. We have done an installation in Kenya for the tea industry as well. And then there's also mining. Actually, the technology that I'm going to be speaking about most today is solar thermal. And if you look at some of the biggest installations of solar thermal in the world currently, they are for mining industry. In Chile, for example, the copper industry, there's huge fields of these solar thermal collectors connected to the mining industry and that desert-like environment. And then there's also the way, obviously, we use heat in buildings. In many countries, it's also common to actually have a centralized factory or a centralized production of heat and distribute that through district heating pipe networks into the city. So that is happening in many cities in Europe. I know that it's happening also in China. It's happening also both on an industrial level, that you have centralized production of heat that distributes into factories, many factories that are connected to this district heating system, as well as buildings. And there's also examples of district cooling, where, again, instead of everybody having their own air conditioner unit in their offices or in their buildings, to produce cooling centralized, use more renewable energy in that centralized production, and then put pipework into the ground which distributes the cooling. So that, I really believe, will be part of the future in campuses, in parts of the city, to produce centralized cooling. There's many great much great research on that. So when we look at a factory like that I've just mentioned, the food and beverage and the textiles, somewhere in the factory, normally at the back, you will find these boilers that are either burning, heavy fuel oil or diesel, or burning coal or gas, natural gas. In the buildings that I have done installations for, you'll find hot water boilers that look something like this, and these are most of my experience with working with solar heating has been in South Africa, where we connected to many hotels. We used the rooftop of the hotel to produce hot water, and we reduced the amount of electricity that they were currently using for producing hot water for the showers or the pools and so on. So these are all electric driven boilers that we can replace by or at least substitute most of the heating demand from electricity. So we use as I said, one part of the renewable heating that I represent is the one which uses the sun. The sun has two forms of energy when we look at it. It has the photovoltaic energy, which is the same way that plants absorb energy. That's the one that you can use to produce electricity, solar PV, and then the sun delivers the other form of energy, which is heat. So those two energy forms are actually not the same. So when you produce PV, you use the photovoltaic and the light of the sun, and when you produce solar thermal, you use the heat of the sun. And actually, a PV panel doesn't like the heat. It actually produces, if you put it likes lots of light, but the hotter it gets, if it goes above 100 degrees for example, in Pakistan maybe, or in the Namibian desert, it will be producing less and less the hotter it gets. So there's great potential to actually combine the two technologies as well, which I'll touch a little bit on. So one illustration that I like to use to wake up to how much energy is actually coming from the sun, we can look at this map and we see that each square meter that is or each part of this map that is a little bit on the reddish orange, light yellow orange here above this side is actually receiving 1 barrel of oil per square meter per year. 1 barrel of oil is 1,700 kilowatt hours. That's how much solar is falling on the Earth's surface per square meter per year in these parts. So Pakistan is very blessed with solar radiation, and obviously most parts of Africa and North and South America, Australia, all of these places have much oil equivalent of solar energy falling on each square meter. So what happens when we, if we look at producing hot water, we want hot water at the tap for the showers, for example. So when we have a coal producing energy electricity plant, so a coal-fired electricity plants, if we start with 100 units, then the efficiency of those coal plants, there's about 70% power losses. Then we have about 9% transmission losses. Then you have the boiler, the electric boilers, about 10% efficiency losses. Then you have the pump losses and the pressure reduction losses. At the end, you end up with about 9.5 units, so like a tenth of the original energy that you put in. When we put something like solar thermal directly on the roof of a building, we can store the heat in the tanks, and this is a simplified schematic of how solar thermal, with the pumps and the pressure vessel and so on, circulates the heat into a storage tank, and then it goes into the building. So we end up with much more energy. It's much more efficient this way to actually use the roof where the energy is already, instead of burning far away the coal and transporting it via electricity, converting it back into heat. When I'm saying solar thermal, there's several different technologies that are suitable for different purposes. There's the ones that are evacuated tube. So they have these round tubes that produce hot water, or flat plate collectors. They are normally good between 20 to 60, or you can push them up to 80 as well. Then we've got the parabolic trough collectors. That is the company that I'm working for at this point, Absolicon, where you're concentrating the heat, and you can reach temperatures between 60 and 160. And then you get something called Fresnel solar thermal, and they concentrate the heat even further. They have many more mirrors that concentrate the heat on one focal point, and they can go up to 400 degrees Celsius. So between these solar thermal technologies, it's possible to play up to 140 degrees Celsius. What is very nice about this solar thermal technology, if you look at the way this is 24 hours, and this is a measurement that I have taken myself from a typical hotel, where the energy consumption of the boilers goes up from starting at 6, 7, 8, 9, and then it goes down. And then it goes up again between 6 in the evening to about 10 in the evening at night. And then we look at the typical, and this is an example of the South African electricity grid, how that the country's electricity grid is peaking at the exact same times as most boilers are going on and off. So what that allows us to do is, with solar thermal, or with renewable thermal in general, instead of adding electricity batteries, which is the equivalent, when you're working with PV, you would add electricity batteries. But in solar thermal, we add storage tanks. And if you upsize those, you can actually reduce this peak. You produce the energy during the daytime, and you store it in these big thermal storage tanks, and you can release it in the evening times. And then you can charge again in nighttime. Normally you can use like a heat pump of sorts, and you charge it, the thermal storage, in the nighttime. So what it does, it can greatly reduce because during these peak times, most countries have a much higher electricity price during the time where the energy grid is very strained. And if we put thermal storage, a thermal battery storage, in combination with this renewable heat pumps, solar thermal, such renewables, we can get much better paybacks than if we use only solar thermal, because of this peak demand reduction. This is just an example of how it can look on a roof, because you are architects. We can heat then with this installation. They are heating both the hot water for the house as well as the pool. And this is actually a technology, again, that can produce both electricity and heating at the same time. It's called PVT. So it's PV for photovoltaic, and T for thermal. So it's a hybrid collector that uses both energy sources at the same time. So here you see the same concept. You put it on the roof, you pump with the pump station into the thermal storages, and then it goes back up again, and the electricity is illustrated in yellow. So the electricity goes to a inverter for from DC to AC energy normally. Here's another example of how the system looks solar thermal. Now I'm going to be showing you some examples of the industrial solar heating. So this is the technology, as I said, that I'm working with currently. It's normally we put it on the ground and put fairly large surfaces we cover with this outside of factories. So if we look at one soccer pitch, we can fit 1 megawatt peak on such a field, and that can replace 250,000 liters of oil, 600 tons of firewood, or 5,000 tons of brown coal, or 300 cubics of gas. So that's how much energy you can expect from a field like this. What happens inside the collector is that it concentrates, so it's a magnifying collector, where the solar arrays all bounce off the mirror and concentrate in this red tube and the red dot here, or in this black line here. That is the receiver tube, where all the solar energy gets concentrated on top of. And this follows the sun throughout the day. We have developed this together with Siemens, so we're actually tracking the sun to always have that concentration wherever the sun is in the sky. I will skip that. This is produced in a automated production line where one collector is produced every 6 minutes, and there's two of these factories currently, and there's the process of setting up more factories, one for example in Canada and one in Egypt, and slowly we're building up a network to produce these collectors locally. So how can we integrate this solar heat into a factory? We look at the current boiler system, and there's many places where the hot water can be connected. So here, for example, we can tie in, we take out heat here, we put this the heat to the solar central, and we add the heat back into the process, and so on. So I'm going to just show you how it looks like, because when I say, replace boilers, I actually mean replace the energy that the boilers is normally using, because you do need to have work in conjunction with another energy source, because the sun is not always available. But here you can see a typical industrial client, where the dark blue line represents their heating demand, and then the dark blue bars is how much energy heat we deliver to the client, and then here is where we're charging the storage tank, the gray, and then we're discharging it in the light blue, and then we have some overproduction. So this client, we are able to meet 49% of their heating demand with renewable heat from the sun, versus using coal or natural gas. For the rest, they would be using the boiler, continue to using the boiler. In the future, it can be combined with other technologies, biomass, biogas, or heat pumps. I'm going to skip some of these slides to jump straight into the battery part of the renewable heating. So I don't know if you've seen if it's very common, but there's these power walls, or there's these battery solutions that exist that you can put in your home. They are normally around 13-15 kilowatt hours capacity, and when you look at how much energy is that actually in heat, it is the equivalent of 3 or 4 logs of wood. So it's heating is a different yeah, it has it's yeah, I find this quite spectacular that we're looking at this and we're thinking there's a lot of energy, but in the form of heat it's not so much energy. The same if you were to look at a 10,000 liter tank, which is very common for us to install. 10,000 liters is a small storage tank for an industry or for a hotel. That is a same amount of 33 of those power walls that I just showed you. And they, so this tank can hold 450 kilowatt hours, and it's 15 times cheaper than to buy this tank. To buy this tank is 15 times cheaper than to buy all of these battery. So it's a very cheap way to store energy. I've seen installations where they have batteries and they produce electricity, and then they use the batteries to produce heating, and that is, in my opinion, not the smartest. So even on the same way that you know that we had different technology to produce the different temperatures, we also have different technology to store the renewable heat. Those district heating networks, they work with something called pit storage. They dig really big hole in the ground, cover it with a certain lining with plastic, fill it up with water, and then put a massive lid on it. And this, they heat the whole summer, and this is an installation in Denmark. They heat this the whole summer long, and then they take the heat in the winter to heat the houses close by. And here you can use the same for, then there's also storage tank. These are just atmospheric. There's the thermochemical storage that can go a little bit higher. There's rock bed storages that use stone material that can go above 100 degrees. You can use pressurized hot water storages. And there's also geothermal storages that can go above 100 degrees. This is new under development, digging very long holes into the ground to actually store the energy for a long time at high temperature. And if you go above 160, normally there will be something like a thermal oil, a phase change material, or this sand storage that can go above 160 as well. I mentioned the other combining technology. So this is one way where you can actually achieve zero, the road to zero carbon heating, where you use the solar thermal. You combine it with those storages that I mentioned. You can combine low pressure and high pressure storage. You add a heat pump to that. The heat pump preferably should be driven with solar PV, and it gets its heat from the low temperature battery. And in the end, you still have like normally the existing boiler, but maybe it's just 1% or 2% left, because it's maybe for emergency or backup when there's a maintenance on something. So normally we recommend to keep it. But this this technology mix, we can go to produce zero carbon, very close to zero carbon for industrial or for residential heating systems. I mentioned in the beginning that it's possible to use the renewable heat to produce cooling as well. There is examples of that in industry. There's also examples of that for buildings where you yeah, I know that one of the IKEA warehouses have done that in Indonesia or something like that. They're using absorption chiller. So there again, we have the solar thermal collector, we have the solar central, we store that in the heat battery, and then the heat goes to those processes, whether this is a dairy or a yeah, the different heating demands for different industry. And then a part of the heat also goes to this absorption chiller. So the absorption chiller doesn't consume electricity other than for the pumps, and it's through a reaction that happens when it's getting this heat, it actually gives the output of thermal cooling, and that you can put into, you know, a air fan unit that fans the cool energy into the building. So that is a neat way to use the solar thermal collectors, get both heating and cooling from the same installation. I will skip a little bit now this and just show you some of those installation. This is from my previous work where we did the hotels, how this looks. We did some of the, yeah, these are installations that we have done. And here you can see some examples of industrial installations. This is now on the roof of Colgate in Greece. This is Nairobi, Kenya, where we actually put the collectors on top of the equipment. So it's a bit of a raised structure that creates shading. This is in Italy. This is in Greece. And this is in Spain, the installation. And this is a district heating in Sweden. So there's a nice tool that you can use on the website of absolicon.com/fs, where you can go to different parts of the world and build a little field. It's just a square, and then you can choose the temperatures, and you will see how much energy can you produce in different locations. So I recommend playing around with that tool to see how much energy can be generated in different locations. So that was all of my slides, and I think we have like 20 minutes for discussion. I will hand over to you, Lala.
Yeah. Thank you so much, Henning. That was really informative. Majabin, do you have any questions?
Yes, here we have two questions in Q&A. Number one is, is this solar heating is for water, right? For heating water, for some kinda use, it is for individual use. It is not for Pakistanis, because a lot of time we don't use electricity for heating water. We use fuel like wood, gas, or really electricity. It is not very clear what type.
Can you repeat? It was a little bit difficult to hear.
Okay, in this question, they are asking that is this solar heating?
The question is about water heating, because I think to the person who asked the question, or audience in general, water heating through solar is something new, and that's what they're trying to confirm. That did you refer to water heating using solar? And on that, I would just request to clear that how solar heating is different from solar PV, because the audience is generally from architectural background and not necessarily energy systems, so they need a bit clarification on that.
Yes, yeah. I mean, if there's the smallest solar heating systems is just one collector with a small storage tank of maybe 100 liters. Those systems have are quite cheap, and they can be installed on individual houses. There's I'm sure there will be those installations also in Pakistan. I think yeah, there's and then, but what I have presented now has been more commercial. My work is very much in the commercial utilization of solar heating. So I focus on industry for residential blocks, like apartments, hotels, universities, any place where there's many people living together and where there's a centralized hot water production. So but individual homes can also have a small system of solar heating, and that has been done for many years already. There's several millions of those systems in China, in Europe, in South Africa.
All right. The second question is about so the PVT. So they say the PVT system will not make reduction in producing electricity as compared to normal systems. It's doing both functions, heating and electricity production, and what will be its life. I think the question, so first part of the question is repeating to what was the first question, but the second part is asked regarding the life of the solar water heating units.
The life of the solar water heating units is, when it's installed correctly, it is 25 years. The most systems that there is solar thermal systems, solar water heating systems that have been around for 35 years, but you have to install it in a way that there's a separation. Normally you use like a heat exchanger, so that the water that you use, for example, in the shower or in the industry or in the pool, is not the same water that goes to the collector. There's like a separation, and you transfer the heat, because it's normally, when you don't do that, you have a lifetime maybe of 3 to 5 years if the water is very corrosive, and that I have seen many times, that those collector systems break very quickly, that run with the water directly into the solar collectors.
All right. We had a raised hand, but that's gone now. So I'll request audience, if you have any questions, please raise your hand and I'll allow you to speak. Meanwhile, we have one more question about, so are there any specific considerations or challenges when we have to implement a renewable heating system in existing or already built environment?
Yeah, I mean, if you are, it's a very good opportunity when you are building a new house. So if you are an architect and you're building you're drawing a new building, so to speak, then it's a very good opportunity to install solar thermal directly from the beginning, because you will be needing to make the pipes down to normally the storage tanks can be in the basement or on the roof, but you need to account for, where do you place everything. If the building is already existing, like the hotels that we did, for example, Hilton and so on, we need to figure out sometimes this way, how do we pull a pipe from the top of the roof down to the basement where the storage tanks is, and that can be quite costly. So if you can, and as well as the roof, for the installation that we did at the Radisson Hotel, we had to reinforce the roof so that it was able to hold the weight of the collector. But if you have that already in mind when you're drawing or when you're building the house as an architect, and you say, okay, this roof should be strong enough to hold the solar thermal collectors, then you can avoid a lot of costs in the future. There's even regulations in Sweden now that when you are building a big house, like for example a barn, a farm house where there's a barn, you have to orientate it towards south. You cannot build a barn facing the wrong direction when you're building it from today, because they want to be able to add solar thermal in the future. So you need to think about the orientation of the building as well, to say, can this roof fit? How can this roof be optimized for future implementation of solar thermal collectors or PV collectors, or both?
We have one more question about are there any other, I think they're asking about design features or architectural features that you might have considered while you're doing the changes in terms of like heating, but that could add towards the heating solution as well. For example, insulation and other stuff.
Yeah. No, insulation is if that is done badly, it can basically ruin the efficiency very much. So we always recommend to do the insulation correctly. Yeah, that would be my main point, I think. Yes. Yeah, the insulation, I think, is the most important point for when you install it correctly.
Yeah, for sure. How can buildings design to optimize energy efficiency in heating systems? Again, like it's also about the building design of the building. If you could help, if you're maybe I can take this question. So building design, the energy efficiency depends what part of the world we are talking about. So it matters a lot if for example, is it Ireland or it's Pakistan, we need different kind of energy performance. For example, in Ireland, we need heating toward better, whereas in Pakistan, we need cooling toward better. And like obviously design features would be really different for those. And we will talk about these in very much detail in our upcoming episode. But to specify your question, yes, it matters, and how it matters, that will be discussed in our next episode.
Yeah.
Okay, so next question is, what considerations are important when integrating renewable heating solutions to Pakistan's diverse building types, from urban high-rise to rural homes? So how does it differ if it's a urban environment or a rural environment?
I guess it doesn't differ that much. I mean, if it's a high-rise building, I would say that it differs how many people live in the building. So you need to size obviously the collector field so that you're meeting most of the heating demand with the sun. So you can calculate one of those collectors that is, maybe 1.5 or 2 square meters big. You can heat, in normal cases, you can heat about 100 liters or 150 liters per day with those. So depending on that differs a little bit in a very posh hotel, for example. The people might consume 100 liters or 150 liters of hot water per day, and in more other parts of the city, maybe there's people consume very little hot water. So you always have to start with that. How much energy demand in terms of hot water is needed, and then you do some simulations that calculate how much thermal collectors you need. You size the storage tank, and then you work out the backup, the heat pump as well, to see how much is needed for the remaining of the water demand.
All right, that were all the questions, and I think my questions are also like they were addressed in between those questions. Majabin, if you have any more questions or comments.
So I think all my questions are also in the questions already Hani explained. There are some more Q&A, I guess, Nada.
Yeah, but they're like the similar and they're already discussed, and like more questions are about the topics that we are planning for our next episodes. So I think it's okay.
Okay, that's fine.
All right. Thank you so much, Henning, for joining us and helping us address this topic. If you have
Great.
any questions from myself or Majapin.
No, I will look forward